Hey, Stephen Barter here, fresh back from Melbourne and our Society of Plastic Engineers conference or breakfast seminar. Had a lot of fun discussing quality control and extrusion blow molding. Now, as promised as part of that seminar, I've put up this bottle profiling Excel folder onto the website so anybody can download that as they require. It's a really cool tool. I'm going to run through it with you right now, but basically this document becomes your quality control. It will tell you where the problems are and how to combat them. So all the information here is on every page, so I'll just quickly jump straight in. So you can see here I've got a bunch of data. So what that represents, so there's 25 segments down here on the left hand side, and that is 25 points on a plastic bottle. Now that would vary depending on the size of the bottle, so you might have 20 points, you might have 35. That's not really relevant at the moment, but what we might do is we will measure the bottle in 10mm increments. So looking at my chart here, from the left to the right is from the base of the neck of the bottle into the shoulder, into the panel, and then into the base of the bottle. So this profile represents that bottle in a graph format essentially. And then over to the right here we've got another little spider graph, and that represents the cross section. So imagine that we just cut a bottle directly in half. Well, that is what we're seeing here at 4 points. So we've got the part line, the handle area, and the front and back label panels. Now in this particular example, that's all measured from segment number 20, which is right here. Now looking at my chart here, so segment 20 is here, so we've basically just cut straight through there on the bottle. And that cross section there that you can see on the right hand side is represented by that. So the data here, as you can see, I've basically drawn a straight line down the middle of the bottle, going from the top to the bottom. This is the back and then the front in 10mm increments, or 20, whatever you think works best for you. And then I've got a range, so I'm just checking to make sure I don't have a big difference between the front and back. And then I've got an average. So that average number here is actually represented by that chart. Now up the top here, I've got some targets for my bottle. So I'm looking for a weight of 88 grams with a top load of 23 kilograms at 5mm distortion. That's a really important number, because if you just go to total destruction on your top load, you will get variable measurements. So I always measure top load with 5mm worth of travel on the load. And in this particular bottle, it's a 2 litre bottle, so we have 2,032 millilitres. That's our target. So in this example, we've just, as an example, we've just started our production. We're running at 92 grams, but we're only achieving a 20 kilo top load, so we're a little bit light on there, and our brimful's a little bit big. So you can see over the side, that's basically the difference between actual and target. So what I'm going to do is I'm going to try and bring the bottle back into specification by using the main adjustments, for example, wall thickness controller, or your Parison wall thickness controller, and your support air. So I've done this in multiple stages, so I'm going to go into the next sheet. So for example, we've produced some bottles. This is the first measure. So we've got these, this is our result, so we're looking to improve. So I'm going to repeat that exact process again, and I'm going to call it stage 2. So I've just jumped onto another tab, and I've had a second round of measurements. So I've made a few adjustments from that first result, and I've made another bunch of measurements, and this is what it's come out as. So the profile is a little bit smoother. I've tried to improve what's going on down at the base there. We've balanced out the wall thickness, so front to back is a little bit better now. And as a result, we've had just a slight increase in our top load and a reduction in our brimful. So we're trying to get to that target, but we've also managed to reduce the weight just a little bit. So what I'm doing is I'm constantly trying to make the bottle better. So I'm trying to get the bottle weight down and trying to get the top load up and the brimful into the target where I need it. And that's all about balancing the distribution of plastic. So I've taken these results, I've gone and made some more adjustments to my wall thickness control and my support air and balanced the process out a little bit. And now I've gone to stage number 3. So in this particular example, we've made all our adjustments and we've done another measurement. So we've got our average measurements again here represented in this line graph, and of course our cross-sectional measurements from segment 20 represented here. So what we're seeing now is a much more smoother profile in the bottle measurements and a balanced cross-section. So as a result, you can see we've got our weight down where it needs to be, and our top load of 25 kilos at 5mm distortion, and our brimfulls actually come back in as well. And that's all about having that balanced plastic distribution. Now what I like to do is I like to learn as I go. So I've basically summarized all of those on the one screen here. So the top chart's representing stage 1, the middle stage 2, and the third stage 3. So you can see the changes that's actually happening as we've balanced that out, and the results here on the right hand side. So what I like to do also is to record all of the changes that I made, just in case we actually made it worse, and that can happen. So we think we're solving one problem and we may create another. Okay, so what do we do with all this information? Well, the one thing that I like to do with it in particular is create a standard. So the third profile there, if that's where our bottle is going to be best, then we need to create a standard around that. So on this particular page, what I've done is exactly that. So I've added another 2 columns here, which is your lower control limit and our upper control limit there. Now they're represented by these red lines. Now the idea behind that is it's just a basic subtraction using Excel, and I'm just plotting a red line, an upper and lower control limit along the blue line there, and it's represented by the red line, and same with my cross section. So why would I do that? Well, let's just say we're in production and we're having a little bit of trouble with our top load or brimful or something like that. I'll go to my troubleshooting tab. So I've got this template here, that's my standard. I jump on and I go and do some measurements, and this is what I find. So the blue line is representing the actual data that's coming out of there. So you can see we're not within the control limits. So the upper and lower control limits are being breached by that blue line. So that tells me where my problems exist. So what I've got to do is actually try and adjust the process back to get those particular parts in place. Now what's important here is if my wall thickness controller document or my setup sheet and my screen are exactly as they were in the previous bottle when we know it was running successfully, then there's going to be something else wrong. So don't go making changes to your wall thickness controller just because you're getting a different result here. You've got to understand where the change was. And that all comes back to understanding what your variables and non-variables are to that process. So I've gone and made some adjustments, and I've got another result here. So again, I've started to get a bit closer here within the red lines. So my upper and lower control limits are a bit closer now. And what that means is my results are going to get better. So again, to tracking the work that you're doing, if I jump onto this last tab here, you can see where we started. So we were well and truly breaching the red lines here, our control limits, and now we're getting very, very much closer to where we needed to be. So on the right hand side, I've basically listed the changes that I've made. So I've adjusted the extrusion die to center, I've adjusted the wall thickness controller. In this particular case, it wasn't set correctly. There's other areas there that I can work on, is my support air, but also making sure that the weight is also correct. So that's the bottle mapping process. If you use this and you use the standard that I've described, every time you have a fault with your bottle, this will tell you exactly where the problem is and what not to do. So you don't want to go adding plastic for adding plastic's sake, you want to get back into a controlled stage. Okay, so hopefully that document was helpful, and you can have a crack at doing your quality control with Excel. I absolutely promise you it will solve a whole bunch of problems. I've been doing it for years and it works a treat. It works on everything from solving existing quality problems right through to optimizing bottle strength. So enjoy, and we'll speak soon. Thank you. Bye.